imaginary numbers were invented, I guess you could say. They came up with them, mathematicians came up with them to deal with equations such as x squared plus 1 equals 0, which actually have no real solution, but you can still solve them. So mathematicians came up with imaginary numbers to represent their solutions. So the imaginary unit I is defined as the square root of -1. And this is useful when working with square roots of negative numbers. All right. But hold on, let me think about this next part. The pure imaginary number is written in the form a plus bi, where a is the real number and bi is the imaginary part. So if we have a radical, and you start off with your radical as the square root of negative number, what you do first is you separate it. You take the negative and you rewrite it as -1 times just the number. And then you break it down if it's not a perfect square. So if the number itself was not a perfect square, you'd simplify that number. And then the -1 becomes an I. And then the number that is a perfect square or not a perfect square, you would simplify as though it didn't have a negative attached to it. So for number 1, we're going to think of this as the square root of -1 times the square root of 9. So the square root of -1 is I. And what is the square root of 9? 3. And so we would say this is 3I. It's weird. You don't like it? You don't like that it's imaginary?
I don't like that it's a dotted I.
Because if you do this on our calculator, square root of -9, your calculator goes, nope, non-real answer, that's imaginary. Oop, but we can work with it now. 3I. All right, let's do the next one. Square root of 196 is square root of -1 times the square root of 196. Is 196 a perfect square? Yes. What is it, the square root, or what's the square root of 196?
15.
14, okay. So this is I times 14, and so it's 14I. I do? I don't have it like on me right now. It's back at my desk. I can charge it for you in a little bit. No. All right, let's look at the next one. Square root of -5 is going to be the square root of -1 times the square root of 5. Does the square root of 5 simplify? No. So we've got I times the square root of 5, and most people write that as I root 5. Miss Rice, how come the I goes after the number on these ones but not on this one? I don't know, it just looks weird. So I don't know, it's just how we do it. Yeah, it's just, yeah, that's true. Yeah, when you simplify it, yeah, you put the number in front. Yeah, that's true. All right, next one. Square root of 80, we've got the square root of -1 times the square root of 80. And can we simplify the square root of 80? Yes. Do you guys want to do the perfect square type of simplifying, or do you want to do the tree? Perfect square. So what perfect square goes into 80? 4. If we do 4, we're going to do a tree, though, because it'd be 4 times 20. 16 is the perfect square, is the biggest perfect square that goes in. 4 is a perfect square that goes in, but it's not the biggest. So 16 is the biggest perfect square that goes in, so we would say we have the square root of -1 times the square root of 16 times the square root of 5. But if you wanted to do the tree, then you could do 80. You could do 4 and 20. 20, you could do 4 and 5. The 4 is 2 and 2. That 4 is 2 and 2. So you would have a pair of 2s, a pair of 2s, and a leftover 5. So we could do this if we did the tree method. Over here, using the perfect square method, we have an I times a 4 times a root 5. And so what's our final answer? Yeah, 4i square root 5. And if we used the tree method, we would have a pair of 2s, a pair of 2s. 2 times 2 is 4, and a leftover 5. 2 times 2 is 4, and a leftover 5. All right, this one, we got the square root of -1 times the square root of 32. Do you guys want to do the tree method, or do you want to do perfect square? Perfect square, what's the biggest perfect square that goes into 32? 16. So we got a square root of -1, a square root of 16, and a square root of 2. So we've got I times square root of 16 is 4 times the square root of 2. So that gives us 4i square root 2. All right, -1, square root 192. Do you guys remember how to use the calculator to find the biggest perfect square? Okay. So, and you got to look for the biggest perfect square, not just a perfect square. Well, 96 is a number that goes into it, but 96 is not a perfect square, so it's not 96. Yeah, 64 looks like the biggest perfect square. So 4 is a perfect square, but it's not the biggest one. 64 is the biggest one. So we're going to say this is -1 times the square root of 64 times the square root of 3. And so we've got I times 8 times the square root of 3. So we have 8i square root 3. How do your brains feel? Brains feel pretty good? Yeah? No? No.
I know it.
Okay. All right, so next we're going to solve equations. This is just what we did last week. We were solving equations taking square roots, but as we solve these equations taking square roots, we're going to get negative numbers underneath our square roots. So we're going to get imaginary answers instead of getting real answers. So for number 7, what should I do? Subtract 81. So we're doing those steps just like we did last week, where we're going to say the first thing is we're adding or subtracting a number over from the x value from the variable. So x squared equals -81. Then we're going to say, oh, is there a number I could multiply or divide over to the other side? No, there's not. Now I'm going to say, is there an exponent I could add in or get rid of? Yes, what could I add in or get rid of? The squared, I could do a square root. And when I do the square root, what do I have to do? Yeah, plus minus, don't want to kill the baby horsey. Oh, and do the -1 there. So what's the square root of a -81? 9i. So x equals plus or minus 9i. Two answers, positive 9i and negative 9i. Not killing a baby horsey. Let's try number 9. So first step, is there something I could add or subtract over to the other side? 15, so I'm going to subtract the 15 over. What's -9 minus 15? -24, okay. Is there something I could multiply or divide over to the other side? 4. -24 divided by 4, -6, okay. Third step, is there an exponent I could introduce or an exponent I could get rid of? What should I do? Square root it. And when I square root, what do I need to put in front of my square root? A plus or minus. So I got a plus or minus square root of -6. And then what do I have to do to make this a proper answer? Put an I in the front. So I'm going to say x equals plus or minus I square root 6. Not killing any baby horsies. All right. All right, I think those ones are pretty good. We're going to move down to this part right here, which says the powers of I. All right, powers of I. So I to the first power is the square root of -1. I to the first power is the square root of -1, which is just I. Right? I squared is pretty interesting because it's actually the square root of -1 times the square root of -1. Would you guys agree with that? Okay. What happens, I'm going to write this off to the side. I squared is the square root of -1 times the square root of -1. So you could basically say it's the square root of -1 squared. What happens if I have a squared and a square root? They cancel out. So that means that I squared is what? I squared is -1. Isn't that weird? I squared is -1. Okay? So here we're going to think of I don't actually know how they want us to fill this out, but I know how I want it to be filled out. So I'm going to write I squared. So this is -1. Okay. All right. Now, here's what I want you to do. Does anyone have colors on them? You guys have colors at your table? All right. Now, that I squared equals -1, that is really important. I squared equals -1 is super, 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 super important. So write that in a color, and then we're going to put a box around it. That is one of the biggest ideas that we have learned today. All right. Okay. Now, I to the third is I times I times I. Would you guys agree? Okay. Now, I times I is I squared, right? And what did we just say I squared was? -1. So this is -1 times I. -1 I. So this is -1 I. Okay? I to the fourth is I times I times I times I. There's 4 of them, right? We have I times I is -1. I squared is -1. And we have I times I is I squared is -1. -1 times -1, +1. For which one? All right, number 5, I to the fifth. We got I times I times I times I times I. So we've got a -1, and we've got a -1, and then we've got a leftover I. So -1 times -1 is +1 with a leftover I. So +1 I. Ooh. How are your brains feeling? Stretched. All right, I to the 6th. What are we going to do?
I times I times I times I times I times I. I times I times I times I times I times I.
Okay, so we've got a -1 and a -1 and a -1. So we've got 3 -1s all being multiplied together, which is -1. Okay?
Let me guess the next one.
Okay? Looks like it. I don't have to take my car to the car wash. Yippee! So we've got -1, -1, -1, and a leftover I, -I. Okay. Okay, we've got a -1 and a -1 and a -1 and a -1. So it's a +1. Okay, for 15 I's, do you want to draw out all 15 or do you want to talk through it?
Well, no, you just have to know if it's odd or even. If it's even, it's gonna be.
Do you just have to know if it's odd or even, or do you have to know more? Okay, so we have to know a little bit more. Okay, so we have to know a little bit more. So, okay, so let's subtract 1 from this. We know that we have a leftover I, right? So we're gonna say 14 divided by 2 is 7. So when I do 14 divided by 2 is 7, what is that 7 telling me? There's 7 groups of 2. Okay? So there's 7 I. So I have 7 -1s being multiplied together. Okay? So I have 7 -1s multiplied. Okay? I have 7 -1s being multiplied together. Now, if I have 7 -1s being multiplied together, is that going to give me a -1 as a result, or is that going to give me a +1 as a result? A -1 as a result, because I have an odd number of negatives. Does that make sense? Okay, so that's going to give me a -1 as a result, all right? And then the 15th I is going to do what? Going to stick an I on my answer. Yep, so -I is the answer. All right, now this one is an even number, so I'm not thinking of having a leftover I. It's an even number already. So I'm just going to do 62 divided by 2, and I get 31. So what does that 31 tell me? I have 31 -1s being multiplied together. 31 -1s being multiplied together. And so what does that mean? Yeah, I'm not going to have any leftover i's. So it's just going to be -1. I had only pairs of I. had only pairs. So I had all -1s, and I had an odd number of -1s. Okay? When in doubt, just draw all the i's out and circle the pairs. Yeah. I mean, it's tedious, but you can do it. You could. That sounds terrible. All right.
I know, imagine having to do that on like a test and then you do like one eye wrong.
I mean, that would be obnoxious, wouldn't it? All right. Let's look at number 15. So we have 4i multiplied by 7i. So what is 4 times 7? 28. And then what is I times I? I squared. And then what is 28 times I squared? Yeah, so this is actually 28 times a -1. So this is actually a -28. Crazy. Crazy. Now, I do not like to have powers of I bigger than 2 if I can avoid it. So what I do is I deal with my i's in sets of 2. That's what I like to do, because anything bigger than that confuses me. So with these ones, instead of letting this get to a 1, 2, 3 power of 3, I'm going to deal with these 2 first and get my power of 2, and then I'm going to deal with the third one. Okay? So I'm going to ignore the third one to start with. What is negative 4i times positive 2i? Negative 8i squared. I'm going to deal with that. I'm not even going to deal with the 9i yet. What is negative 8i squared? Negative 8 times negative 1. I'm still not dealing with the times 9i. I'm going to leave it there. What is negative 8 times negative 1? Positive 8. I'm just going to leave it there for now. Okay. Now I can go through and multiply times 9i. What is 8 times 9i? The I is a square root of negative 1, and we don't have to introduce a square root of negative 1. We can just leave it as an I. So now we're just going to say 8 times 9 is 72i. It's not an I squared. Good question. Yeah, so what I did is I didn't, if it were me, I do not want to have to memorize all of these. Does that make sense? I only want to have to know I squared is negative 1. Say it again. Oh, yeah, you guys are right. Negative. So negative 72i, is that what you guys were saying? Okay. Woo. Ugh. They are being tricky on number 17. They are making us deal with an I to the third. Shame on them. Shame on them. Actually, not quite. We can manipulate it. So they said 2i to the third. So we've got 2i times 2i times 2i times 5i. Does that make sense? You guys cool with that? Okay, here's what I'm going to do. I'm going to multiply these 2 together, and I'm going to multiply those 2 together. See how tricksy I'm being? So rebellious. Okay. I'm telling Gina. All right, 2i times 2i is 4i squared. 2i times 5i, 10i squared. Okay. What is 4 times I squared? Negative 4. What is 10 times I squared? Okay. And then negative 4 times negative 10. Boom. Wasn't that so tricksy of us? I feel like we just beat Gina at her own game. I think so too. All right. Squared, squared. So we have I root 3, negative 8i, negative 8i. So we'll do these 2, and I'll do these 2. What is root 3 times root 3? You can think of it as the roots canceled out and it gave you a 3. Root 3 times root 3, the roots canceled, it gave you a 3. Or you can say root 3 times root 3 is root 9. Which way do you guys want to think of it? The roots canceled? Okay, root 3 times root 3 is 3 because the roots canceled. And then I times I is I squared, right? Negative 8i times negative 8i is 64i squared. All right, what do the I squareds do? Make the number negative. So 3i squared, 64i squared, and then if we multiply those together, what do we get?
What's the other method of like the root trees? Is it that you multiply them together and then you get square root 9 and then that becomes 3?
Yes. Yep. Yes, Nate.
For the I squared root 3, when you multiply the 3.
Say it again.
When you multiply both of the 3, would it be I squared?
It would be root 9. Root 3 times root 3 is root 9, which is just 3. So the way we did it is we thought of it as root 3 times root 3 is kind of like root 3 squared. And then we said like the root 3 and the squared cancel and we just get 3. So 2 different ways of thinking about it, but it accomplishes the same thing. Yeah. All right. Now this one, they did the i's differently. We've got a negative underneath. So how do we handle these ones? So we have an I square root 18. We have an I square root 10. Does the square root of 18 reduce? Does that have a perfect square in it that can simplify? 2 and 9. Okay. So we're going to say that this one right here is I times the square root of 2 times the square root of 9. This one is I times the square root 2 times the square root 5. Okay, over here, I'm going to leave, well, this is kind of confusing, but we'll go ahead and go with it. Okay, so we have a root 9, which is a 3. Would you guys agree with that? Okay. What happens with the root 2 and the root 2? What's root 2 times root 2? I'm going to call it root 4 to not be confusing. It's just 2, but it's going to be confusing if I treat it the same way I treated the 9. So I'm going to do root 2 times root 2 is root 4, okay? So I'm going to take these two and I'm going to draw arrows. I'm going to say this is root 4. Root 2 times root 2 is root 4. I want to treat it differently than I treated the 9, okay? The root 5 doesn't simplify at all. I'm just going to drop that down. Are you guys okay with that? All right, and then what happens with the I times the I? I squared. Okay. All right, let's simplify a little bit more. What's the square root of 4? 2, okay? So we've got I squared times 2 times 3 times root 5. And what does that give us?
-6.
Okay. That is funky, huh? Good job. Yeah. All right, last one. So for number 20, we're going to say -1 root 24, -1 root 3, -1 root 2. So for each of the -1s, I have an I. What should I do for the root 24? 6 and 4? So I can do root 6, root 4, and then I'm just going to keep the root 3 and keep the root 2. Okay. All right. Now we have an I and an I, which makes a what? I squared. I'm going to keep my I squared separate from my third I. Are you guys okay with that? Why am I doing that? Yeah, because one of them's a -1 and then the other one is not. Does that make sense? One of them's a -1, one of them is not. Okay, so I took care of my I's. All right, what else do I have? I have a root 6. Okay, what else do I have? A 2. What else do I have? A root 3. What else do I have? A root 2. What happens if you break down the root 6? It's a root 3 and a root 2, right? Okay, I'm going to erase the root 6, and I'm going to do a root 3 and a root 2. Okay. What is root 3 times root 3? A root 9. Root 3 times root 3 is root 9. Okay. What is root 2 times root 2? Okay. And we still have that 2 just chilling there. What's the I squared? -1. And then we still have the I. I'm going to put the I over here on the end. So there's not necessarily a right way versus a wrong way to do this. I'm grouping up my numbers based on how I know that numbers work together. So I know that a root 3 times a root 3 is a root 9. I grouped them together because I know they work together. Does that make sense? So it's not like, oh, Miss Rice knows a magic way to do this. I just recognized like, oh, root 3 and root 3, they work. Okay, so what's root 9? What's root 4? And then we have a 2. We have a -1. We have an I. So what happens if we multiply all those numbers together? -12. -12i. You guys see it? -12i. The way that we did the problem was not the only way to do the problem. There are other ways you could have done it. Okay. How are you guys feeling about the i's? So basically, after today, you need to understand that if you have the negative underneath the square root, you basically take the negative out and you put an I. So we understand that? If you have a negative underneath the square root, you take it out, put an I. And that I squared is -1. Those are the two things you need to know. Does that make sense? Yeah. Okay. All right. On this page, we're not going to do this whole page. We're just going to do a few of these problems. All right. Square root of -64. What should we write? 8i. So we're going to make this a positive and just stick an I in the front. So that is just 8i. That is the answer. (10i) times -2i. We got -20i squared, which is 20, positive 20. Okay. Square root of 1/9. 1/3. Okay. What should we do for number 4? Combine like terms. So this is called a complex number. It's a little bit real, a little bit fake. 15 is real, 8i is fake. 9 is real, 3i is fake. So what we do is we put the parts that are real together, we put the parts that are fake together. So we're going to distribute the negative, and not distributing a negative, I believe, kills a fox. Is that right? Can you see that, Pete? Is it a fox? On the very right side in the middle? Is that what it? Okay, so if you don't distribute a negative, you are killing a little baby fox. So we're going to do 15 minus 8i minus 9 plus 3i. And then this is basically combining like terms. We are putting the real portion together. 15 and -9 gives you what? Positive 6. And then -8i and positive 3i gives you -5i. And so the complex number answer is 6 minus 5i. So this is considered to be one answer, like one number. It is a complex number that has two components to it. It has a real component and a fake component. So it's considered to be one number. Part real, part fake. Okay? Kind of like, you know, how you have those complex friends. They're a little bit real, a little bit fake. You know what I'm talking about. You're in high school. You've been there. Okay. All right, with these, what do you guys think we do here? We FOIL. We're going to FOIL. FOIL. All right, 3 times 9 is... Sorry, 4 times 9, I was thinking 36 is the answer. I was doing the answer in my head already. 4 times 9 is... 4 times 5i. -I times 9. And then -I times 5i. squared. Okay, and we know we got it right because it makes our little moon. All right, negative 5i is actually, or negative 5i squared is actually positive 5, okay? So we take the positive 5, we put it with the 36, and that gives us 41. So we have 41, and then we take the 20 and the negative 9i, and we put those together, and we get 11i. There's our complex number. Okay. I to the 41. Take a moment, see if you can figure out what I to the 41 should be. I to the 41. Don't say it yet. Take a moment. Take a moment.
Oh, I know.
You can draw it 41 times. Sophie said, challenge accepted. That's what I shall do. Anybody want to say what they think? We think it's just I.
I thought it was negative I.
I thought it was I.
Negative I.
I, negative I.
Negative I.
I, negative I.
Negative I.
I, negative I. I, negative I. Okay, so we have an extra one left over, right? Okay. And then we have 40 divided by 2 is 20, right? So there are 20 negative 1s that are being multiplied by each other. If you had negative 1 multiplied negative 1, negative 1, negative 1, negative 1, negative 1, that's an even number of negatives, which means that all the negatives are going to cancel out, and you're going to get positive I, positive I, positive I. All right, so here's how the assignment's going to work for today. All right, listen carefully. On the front side, you have, these are called complex number operations, so adding, subtracting, multiplying. I'm going to hand this to you in a little bit. I'm going to hand this in a second. So complex number operations on the back side. You're going to have some problems that you're going to solve with the quadratic formula. You're going to have some problems that you can solve by taking square roots, okay? So you'll know that it's a quadratic formula problem if you have v squared, v, and a number, if you have all three terms, the a, the b, and the c. You'll know that you can do it by taking square roots if it just has the x squared term and just the number, because then you can just isolate the x squared term. So it's got a mixture of those problems. On these, the taking square roots or the quadratic formula problems, every single answer has an I in it. Or I think it should, if I made the worksheet correctly, okay? So front side is doing the operations, back side is quadratic formula and taking square roots. Everything should have an I. Any questions? Good. You're in for a ride, Bentley.
You're gonna be